So hello guys, welcome back to my channel Code Shiva, where I'll be posting about DSA solutions each and every day, and today is day 7th of doing so. The problem that we need to solve today is search in a rotated sorted array, and it is lead code problem number 33. So let's check out the problem and see what it is. Hmm. So essentially in this problem provided with a we will be provided with an array and target. What we need to do is that we need to find whether this target is within this array or not, and we'll need to return its index after finding out, like if 0 is present within this array, we need to return its index. And this searching should be done within big O of log n time. If the target is not present in the array, we'll have to return -1. Okay, so let's take an example, and from there on I'll explain you in detail. So 3 4 5 6 7 0 1 2, and we'll be provided with a target which is 0. Okay, so we'll be provided with a target, and we need to find whether this target is within this array or not. The first thing that comes within our mind, the very first approach, is linear search. Okay, let's write it in short: linear search. And but of course, the time complexity of linear search is big O of n. So we cannot choose this solution, as in linear search it is required for us to visit every element until we find the target, which will in the worst case take big O of n time complexity. So this solution is not required here. What are we gonna do then? The second approach to this problem, which can take us to big O of log of n, is binary search. Yes, since in the problem it is given that array is sorted, the array is sorted, and we need to search. So an algorithm which searches in a sorted array, it is also rotated, but in a sorted array within within this time complexity is binary search, right? So how the time complexity is there, in short, what I'll tell you is that how binary search is used to for us search within the array. In binary search, what we essentially do is break down the array into sub-arrays which have n by 2 of size. Like we break down this array into halves, and then we solve these halves. We don't need to go in both of the direction, we will just choose one direction depending on the algorithm itself, wherever the target would be. So what do we really know about it is that we will have a mid, we will have a low, and we will have a high. If target is greater than mid, then we will go towards the right. If our target is somewhere between low and mid, or smaller than mid, then we will go at the left hand side. Right, so we will be breaking down a certain array into halves until we find the target, and within every half we will do the same thing, repeated work. We will take a mid, we will take a low, and we will take a high, and we will be doing the same thing again and again until we find a value of the target within the mid, or within one of these three, within low or high. Yes, so that's it. So now within this problem, since it is the basic approach of binary searching. But now the problem given to us is that the array is sorted, but it is also rotated at a pivot point, right? So 3 4 5 6 7 0 1 2, right? Target given to us is as 0. At this point, what we need to do is that we need to find whether our we will be doing the same thing as we always do. We will take a low, we will take a high, and we will take our mid as well. But like every other binary search problem, where like in a very normal binary search problem, what happens is that our low is always smaller than or equal to mid, and mid is always smaller than or equal to high. So this is the very basic like relation between these three pointers. If we can somehow use this logic in this problem, then we will be able to solve it as well. How so? First thing in binary search is that we need to break an array into half. We need to figure out how we can break this array into half. To break this array into half, what we can definitely do is first find out that which part of the array is sorted. Can we figure that out? Can we figure that left side of the array is sorted or not sorted, and right side of the array is sorted or not sorted? If we can somehow figure that out, our problem becomes easier, because then we can eliminate a half. A half is a huge chunk within the problem. So we need to figure that out right now. Let's see how we can do that. Now to do this, we have to see that if there is a sorted array, it will have this relationship between these three pointers. Is even half of this relation true? What I mean to say, if left is sorted, then left will always be smaller than or equal to mid. Or if right is sorted, then mid will always be smaller than or equal to high. One of these two conditions will always be true. As you can see within this array, low is smaller than mid, which tells us that the left half of the array is sorted, but mid is smaller than high is not true here, because mid is greater, mid is 6 and high is 2. That is why we can identify this half as unsorted half, right? So first thing first, we figured out where the sorted part is within the array. Now after knowing that where the sorted half is, the second thing that we need to do is we need to find if target is within that half or not. We need to figure out if whether the target is in the sorted half or not. First of all, we figured out, yes, let's say left is the sorted half, right? Now we need to figure out whether 0, the target exists within the sorted half or not. As we can just directly see here, the target is not at the sorted half, it is at the unsorted half. Then we will have to define logic to go to the unsorted half. For that, we will be updating our left pointer at mid plus 1 here, or vice versa. If the situation would have been that the target is 4 and we will have to go here in this sorted half, then we will have to update high at mid minus 1, right? And we will continuously do this process, this everything that we have been doing, this algorithm will be continuously applying this algorithm until or unless we find our target. And in case when we don't find our target, we just simply have to return -1 when we don't find our target. So now let's directly jump down to the implementation of this problem. Okay, so this is case 1 when our left half is sorted. If this condition is true, that means the left half is sorted and we need to if so now for target to exist within the left half or the sorted half, we have to have a condition where target is greater than our low and smaller than mid. Yes. This is not case 1, by the way. The first thing that we need to do is this case 1 when mid is target. So okay, low and nums of mid. So if our target is between these two pointers, what are we gonna do is we will take our high and update it to mid -1, else we will take our low and update it to mid +1. This is it. Now we'll have to do everything again, like when right half is sorted. So when right half is sorted, then mid should always be smaller than or equal to high. That is true. If our target has to exist within this sorted region, then our target should be greater than mid and smaller than high. If that's the case, we will update our low pointer to mid +1, else high to mid -1. That's it. Let me check. Everything is fine. This is the entire solution. Let's see if it is fine or not. So there is a little problem. Expected. Uh, I should return mid here. So yes, now our code is fine. You can finally see that. Let me submit and find out if this code is also optimal or it works for every other case. So yes, our code is running fine, and that's it guys. Thank you for watching this video, and thank you for supporting me. It means a lot.